Hello dear students. In this lecture, we will see some additional problems of gyroscope, okay, and understand their solutions. Now, let's see the first problem. Here, a flywheel having a mass of 20 kg and radius of direction of 300 mm is given a spin of 500 rpm about its axis, which is horizontal. Now, there's a flywheel like this. Its axis is horizontal. So this is kind of an axis. Okay. So it is given a spin of 500 rpm about this axis. Clear. Now the flywheel is suspended at a point that is 250 mm from the plane of rotation of the flywheel. So it is suspended here, okay, which is 250 mm apart from the flywheel. Okay, this much is 250, right? So this is a plane of rotation, isn't it? So this flywheel, wherever flywheel is there, that is the plane of the rotation. So it is suspended here. Now find the rate of precession of the wheel. So there will be precession because of this, because it is supported here, okay, and there is its weight here, okay. Because of the weight, it is, see, first of all, this is an axis. So about this axis, we have given a rotation already. So now there is an axis like this, and there is another axis in this manner. So you see this mg, this force is going to rotate the tending. It tends to rotate this whole system in this direction. Okay, because you can see. Let's just have a look at this one. This is the load. Okay, and because of the load, the flywheel will try to come down here. Yes, so because this is going to rotate like this, no, because of this load, and this is supported here, so this is going to move in this direction. Flywheel is going down, but it cannot go away from this point because it is fixed, suspended at that point, right? So we have given two movements already, so one spinning and one because of its own weight, and because of that thing, there will be a precession about the third axis. This is the axis, and about this axis we have a rotation. That is the precession. So what is the rate of precession? It is what is asked. That's omega p. So you know how to find the omega p. So first you have to use this equation. Couple equation C equal to I omega omega p. And to find out the couple, what is the couple? The weight of the flywheel multiplied by the length where it is suspended. So this is the flywheel, and from this point it has been suspended. So mg will be the weight of the flywheel. So flywheel's mass is, let's say, m. So m into z is the weight multiplied by this length gives you the couple c. Okay, and you know how to find this I. So I can be found as mk square. Okay, so mass into radius of gyration square. From there you can find out I. Now, uh, what are the given things here? So mass of the flywheel is given 20 kg. L is the, yeah, L is the distance of the flywheel rotation plane from the point of suspension. That means from, this is the flywheel rotation plane, flywheel is here, and this is the point of suspension. From here to the flywheel, there is a distance, that is 250 mm. So small L is 250 mm or 0.25. Sorry, this is not mm, this is meter. Okay, so 0.25 meter. And this K is 300 mm radius of gyration, that is 3.3 meter. Okay, then N is given as 500. So from here we can get moment of inertia mk square 20 into 0.3 square, and omega is 2.25560. So from here we have got both of them. So we can now calculate by putting the values here. C equal to I omega omega p. Omega m is 20, z is 9.8, L is 0.25 meter. I we have got as 1.8, omega is 53.36. So from here we can get omega p. It starts. Let's look at the second problem. A disc with radius of gyration of 60 mm and mass 4 kg is mounted centrally on a horizontal axle of 80 mm length between the bearings. Now in this case, we have a disc, okay, where it is put between bearing. So here this side also we have a bearing. Okay, bearing is a support only. This kind of support is there, and the other side also is supported in a bearing. So this type of support is there, right? So what is said? The weight mass of the disc is 4 kg of this disc, and the radius of gyration is 60 mm for the disc. Okay, and it is centrally mounted, means it is in between these two. Okay, at the center of the axle. So this horizontal axle length is 80 mm. So from here to here, the length is 80 millimeter. Okay. So this is shown here. You can see this is the disc. Okay, this is actually drawn in the solution part. You have to draw it yourself. So this is an axle. This is the disc here. Okay. So disc is spinning with an angular velocity of omega. Okay, and also it is supported by two bearings A and B. Now let's read the question further. Okay, now it spins about the axle at, axle at 800 rpm counterclockwise when viewed from the right hand side bearing. So you are now here. Which side, which is your right hand side? This part. This part is your right hand side. This part is your left hand side. I'm standing here. I'm facing that part. Okay. So my right hand is this. Okay. My left hand is this. So this is our my right hand side. This is our left hand side. When I view from the right hand side, view from this side, then I see the disc is moving in counterclockwise direction. Counter from right hand side. So that's why we have shown it here. This is the rotation counterclockwise from this side. If you view now, okay, the axle precesses about a vertical axis at 50 rpm in the clockwise direction when viewed from above. So axle precesses about a vertical axis. This is the vertical axis, and this is the precession. You know, this is called precession. So axle precesses at 50 rpm. We don't know this omega, but we know its speed. Okay, that is 50 rpm. So using this 50 rpm, that is NP, you can call NP. Okay, precession speed. We can get the precession velocity. Okay, this is in clockwise direction. If you view from the top, this will be your direction in this case. Sorry, if you view from the top, sorry, the direction is wrong. This will be the direction, clockwise direction. Now, determine the resultant reaction at each bearing due to mass and gyroscopic effect. First thing is, uh, it will have a gyroscopic couple like this. See here, this we have a support. Rw is the uh, support, actually reaction because of weight. Weight means the actually I have written W for weight. So Rw at point A, here Rw at point B. Okay, so both are supports. Now this disc has a weight, the mg. Okay, disc has a weight mg because mass is there. So about A, this is going to create a couple like this. Okay, like this. So this we need to find out that type of couple first. Okay, so how will you find that? We need to use this formula, I omega omega p. Every information is given here. M is given. Okay, K is given. So K is your 600. See, uh, radius of gyration is 60 mm. Okay, so not 600, sorry, 60 mm. So 60 divided by 1000 is 0.06 meter. So M is 4 kg given. N is 800 rpm given. And P is the precision speed. This is about another vertical axis. This is the precision speed. It is 50 rpm given. L is 0.08. L is actually from this point. I mean, we always have the length here. Total axle length actually. In this case also previous one. Here we have taken the previous example. This is the flywheel, and here it was supported. So total axle length is L. Here total axle length is 80 mm, that is 0.08 meter. So we can find out omega and omega p using this formula. Okay, so 2 pi 800 is the speed in this direction. Okay, omega. So about the axis, and 50 rpm is the speed of precession. So using that 2 pi into 50 by 60, we have found out omega p. Now we can find out the couple from this equation. I into omega p, which is equal to mk square into omega p. M is 4 kg, k is 0.06 square multiplied by this omega value and omega p value. We have got this couple. So this is the value of couple. So it's we can observe that at point A, the reaction couple is clockwise as viewed from the front. So see, because of this part, there is a couple formation like this. Okay, or you can just say that this force is downward, right? And this force is upward. So this is the direction of couple, right? So here you see this couple is tends to move this bearing upwards, and because of this couple, okay, we have, see, this couple is trying to push the this bearing downward, okay, downward, right? So we have that type of force due to couple. So here we will write those additional forces because of the couple as rg. rg G means gyroscopic couple. So here because of that we have a upward tendency in this A because of this rotation. See, this rotation. You can actually replace this by these two. Okay, these two bearings. So this is the couple, right? So because of that, we have an upward reaction here. This RG. This is downward action. So they are asking determine the resultant reaction in each pairing, right? Due to mass and gyroscopic effect. Due to mass is actually this RW and RWB. See, due to mass it has own weight. So because of the weight, there will be some reactions. Those you can easily find out from mechanics. And additionally, you need to find out this RG. These are reactions because of the couple. See, this is the couple rotation, right? So because of that, we have these reactions. Right? Okay, now yeah. So now here you can see that therefore reaction at A due to gyroscopic couple C is C by L. Okay. So because of C, this is the moment, okay, divided by the length. If you take a moment at point, let's say A here, huh? So the if you find the moment, then this will be this couple value divided by the length. That will be the force. Okay. I'm sorry. If you want to find out at A, you have to take the moment at B. Get this divided by L, total length will give you the force here, upward force. Okay. So this is the upward force. Fine. This is 79. Now if you take moment at B, okay, you will get the same value because the length is 80 mm. If you take moment at B, this moment, I can say this is a couple of moment divided by this length will give you the same value, 79. But in this case, this is downward because you have seen this. Okay, this is downward, this one was upward, right? So we have got the forces as 79 at because of this gyroscopic couple. Here we have got this 79. Here also we have got 79, but both are in opposite directions. So in this case, you see at reaction A, both are upwards. So you add them together, and in this case, one is upward, one is downward. So we have to subtract each other. So this force minus this force, whichever is greater, that force minus the smaller force. Here both the forces have to be added. Simply those are the reactions. So you have to find out reactions also. So due to weight of the disk, so weight of the disk is mg 4 into 9.81. So we have got the weight as 39.24. So reactions at each bearing here, the reactions we can find by taking moment. Okay, so moment at point A, if you take, so you know this from mechanics that this force is mg only, mg multiplied by this distance divided by this distance. Okay, so this distance is 80 by 2, that is 40, okay, or 0.04 mm. So 39.24 into 0.04 mm divided by 0.08, which gives it as 19.62. This is actually a shortcut we have done here. So this is a very simple thing that we have done till now. The mechanics, from mechanics we have taken the moment. Just by taking the moment about A, we can get a reaction at B. Similarly, by taking moment about B, we can get a reaction at A. Okay, so both of them will be equal. So we'll got it as 19.62. Okay. So very simply, you can just divide this 39 by 2. 13.2 by 2 will get this as 19.62. Because you see, this is the force, right? Force is 39 point something. So this will be half of that. Half of it. Without taking the moment also, we can take. This is 39 something. 39 divided by 2 will give you 19 point something. 19 point something percent. Okay. So like that. So this is 19.62. So both are upwards because the weight is downward. So simply now these two forces are in the same direction. Add them. So reaction at point A, you add them, these two forces, and reaction at point B, you have to subtract the smaller one from higher one. So in this case, this is smaller, this is higher. So 79 minus this weight. Okay, 19%. So this gives you 59.4 at your uh, this bearing B, and this A it is 19.6. These are actually reactions because you see, otherwise the whole thing is downward because this is 17 is downward. These are both of them are upward. So the reactions will be the opposite. Out of that, this one is downward at A, this one is upward at B. These are actually the resisting forces you can see. The 59.4 is the total resultant force which is downward. So for to resist that, we have to give it an upward equal force. That's why reaction, total reaction at B, reaction we are finding out, reaction is upwards. Similarly, reaction at A is downwards. Okay. Here we finish the problems of gyroscope. Now we'll look at another small problem of riveted joint. Here we have two plates. Two plates A and B are joined by means of riveted joint as shown in figure. So these are two plates. There are four rivets here. Both the plates are in lap joint, and we are being the plates are being pulled by a force P. Okay. So the diameter of the rivet is D, small d. Okay. Now the permissible stress and shear for the rivets is 60 Newton per millimeter square. Okay. So what will be the required diameter of the rivets in order to withstand a load of 50, in order to withstand a load of P equal to 10 kilonewton. So here, so they are asking what should be the diameter if we give a force of 10 Newton. And one more question is there, what will be the effect of shear stress if one more rivet is fitted at the diagonal pitch? So diagonal pitch is here. So if you place one more rivet here, so what will be the effect on the shear stress? So now just simply use this formula. You know that shear force equal to pi by 4 d square into tau max into n. N is your number of rivets. So this formula we have learned already. So from your force equal to area into stress, isn't it? So stress is tau max, area is this one, riveted joint. So there are how many rivets are there? Four rivets are there. So you have to multiply by 4. Okay. So because four areas are there, no? Four areas will we need to save from failure. That's why this is 4. So PS, this is the pulling force here. Okay, that is causing the shear. So shear force is 10 in kilonewton. Okay, here this is into the numerical Newton, which is equal to pi by 4 d square multiplied by 60. 60 is the value of tau max. Okay, into 4. So 4 is the number of rivets. Okay. So from this equation, we can get this diameter as 53.05 millimeter. Okay. So each rivet will approximate it as 54 millimeter. So to withstand that force of 10 kilonewton with a permissible stress of rivets is, for each rivet is 60 Newton per millimeter square, we should have a diameter of 54. Now if one more rivet is placed, so that makes the total number of rivet as 5. Okay, and we will take the same diameter for each of the rivets. So what should be the shear stress? So using the same equation, here put the force. Okay, diameter is now 54 mm. We convert it to meter. 54 is number 3 minus 3 meter. So this is square multiplied by tau is unknown multiplied by 5 because now number of your number of rivet is 5. Okay, so from here, if you solve the entire equation, so you get this as tau equal to 0.873 Newton per millimeter square. Okay. So the shear stress of in this case, if we insert one more rivet here, that reduces. Okay, and in this case, we need to use higher diameter. Okay, so for that, then only we can withstand we can actually save the joint. Okay, so for 5 rivets, what you have to do if you want to keep it the shear stress for each rivet is 60, that is the permissible stress. Okay, so then you have to put 60 here, put 5 here, and calculate back the diameters. What should the diameters be? Okay, here in this question they are asking what will be the effect of shear stress. So in this case, shear stress reduces. Okay, if you want more, if it is placed here at the diagonal pitch. Okay, so we finish this lecture here. So if you have any doubts, you can ask me later. Thank you.